We'll proceed in summation to integral. Okay, summation to integral discussion we are discussing, and it is really hot now. The discussion is really hot now. Summation to integral calculus, and we took example of n coins. There we came to summation. Okay, when we took example of n number of coin, if I have n number of, I really have n number of coin. Yesterday I got some coins. Okay, so I have, I have n number of coins. Too many. Okay, probably 20 coins I have. Okay, I have n number of coins. Consider it is of single piece. N number of coin if I throw. What is the problem that we are tackling now? N number of coins if I throw, then it falls in a series. Oh, it fell like this. Okay, I have n number of coins. It is too many. N number of coin fell fell in a series. Oh, I'm sorry. Okay, one went somewhere. Okay, looks like more or less we are done. Okay, I have now n number of coins. N number of coin. I'm throwing like this. When it falls, it comes in a line. When it comes in a line, then from left to right, I am now counting now. If it comes head, okay, this coin can, I have one 20 rupee coin. 20 rupee coin. This is rupees 20 coin. I don't know, it will be visible, I believe. 20 rupee coin. And it was built, it was no date, 2024. Okay, looks like it was casted in 2024, 1 year back. 20 rupee coin. This is called devaluation of Indian rupee. India has come. I have one old coin of 5 rupees. Okay, this is 5 rupee coin. This is 20 rupee coin. More or less they are similar. Means old 5 rupee coin is same as 20 rupee coin now. This is the condition of this country. Anyway, now if I throw a number of coin falls in. If it comes head, if it comes head, then I draw a random number between 0 and 1. This is what we are discussion we are bringing in. Proceeding now. If it comes head, if it is comes head, then I draw a random number. I draw a random number between 0 and 1. If it comes tail, then I draw a random number between 3 and 4. Makes sense? 0 and 1, one random number I get, and I paste it on the, consider, this is the coin that I am seeing, 20 rupee coin. Now I am saying, oh, it is really head. Okay, I can see it is head. If it is head, then I go and get a random number between 0 and 1. Whatever. Randomly, I select a number between 0 and 1. And whatever the number is, I paste on this coin. Then I see next. If it is a head again, I go again and I select a random number between 0 and 1. And then random number between 0 and 1. And then I paste on it. If it comes tail, then I go and select a random number between 3 and 4. Whatever the number is, I paste on tail. Like that on a head and tail, I keep pasting. If it is head, the random number between 0 and 1, I paste it on head. Random number 3 and 4, I paste it on tail. Now add from left to right and tell me what. That is the question. Tell me what it is. How I can say that is what this is called average. There are two things that is kind of famous in statistics. One is called average, average, and one is called deviation. From average, how much is the deviation? One is average and one is deviation. In a class, there are n number of students are there, and they appeared in an examination. They appeared in an examination, and in that examination, they secured marks. Okay, out of 0 to 10, they secured marks. Okay, what is the mean marks of the class? Add all the marks out, add marks of all the students. If a student count is n, divide it by n. That is the average mark. Consider average marks of the class. It comes as 3. 3 is the average marks of the class. Okay, then what? There is something called average mark. That is called mean. There is something called deviation. Deviation means all other marks in the class, that is 3 to 10 and 3 to 0. Okay, see what is the deviation. Deviation means if someone is getting 7, then deviation is 4. If someone is getting 10, then deviation is 7 from the mean. If someone is getting 0, then deviation is 3. Okay, high deviation means from the mean, marks are scattered. Deviation is very high. So there is a measurement called squared deviation, a squared deviation or standard mean or variance. There are few things that is someone should understand. Mean, variance, a square root of variance is the standard deviation. Deviation means from mean how much the other data are located. If they are located far from the mean, then deviation is high. If deviation is less, means all the data are near. Okay, what is the average marks of the class? Average marks of the class is 3. What is the deviation? Deviation is 2. Means maximum people are from 2 distance from 3 only. Means maximum people they got marks between 5 and 1 only. What is the deviation you are seeing from the mean? Deviation is 2. Means maximum student they got mark around 5 plus 2 and 5 minus 2. In loose term we can say. How much is the deviation? Deviation is 4. Okay, average 4 means maximum students got marks between 3 plus 4, 7, 7 to 3 minus 4 minus 1 means 0 to 7. In this, so deviation if it grows more, what is the deviation of the mark? It is 5. Means marks are scattered from the mean. What is the deviation? Deviation is 0. Deviation, what is the average marks of the class? 3. What is the deviation of the class? Deviation or variance? 0. 0 means everyone got 3 1. Everyone got 3 only. Okay, we can think about a function where there is a convergence. Means deviation is converging toward the mean. These we will talk. These are called precursor in artificial intelligence. Someone must understand this concept and then multi-dimensional calculus, because at the end calculus will come to calculate this. Anyway, right now calculus is there to calculate the average what we are getting. If I throw a number of coin, with each coin if it is head, I draw a random number from between 0 and 1. If it comes tail, I draw a random number between 3 and 4. Accordingly, I paste those numbers on head and tail of the coin. And then if I add all, then tell me what it will be. Someone would say, not guaranteed. Because first of thing, there are two uncertainty here. One is called digital uncertainty and one is called continuous or analog uncertainty. Two uncertainty is there. One thing that is for sure is if whatever I'm trying to say, there it pass through first uncertainty. What is first uncertainty? First uncertainty is how many heads are there. Okay, if k number of heads appear, then k times I will draw a random number between 0 and 1. Whatever is comes, then I'll add. If there is k heads are there, then n minus k tails are there. N minus k times I'll go and withdraw a number between 3 and 4. Okay, in that fashion, every time whatever I get a random number between 3 and 4, that number I'll add n minus k time. Then I'll add all together, it will come. So first uncertainty is I don't know how many heads will come, because for head rule is different and for tail rule is different. Consider rule is same. Consider rule is same. If it comes ahead, if it comes ahead, then I will hit my head one time in the wall. Think in that pattern. If it comes ahead, then I will hit my head one time in wall. If it comes tail, then again I will hit my head one time in wall. Now tell me, if I throw n number of coin, how many times I will hit my head in the wall? N times. Okay? Because now it doesn't matter how many head you get, how many tail you get. Make sense? Okay, if I get a head, if I get a head, then I will hit my head in wall. That is the next wall, this wall, what I am seeing from my eye. Okay, if I get tail, then I will hit head in the back wall that you can see. Now tell me that what is the average, what is the kind of how many, if I consider hitting head in the front wall is 1, and hitting a head in the back wall is -1. If I add all, if I throw n time, then tell me what how many number it will come. It depends upon number of head. This is how here also. It depends upon. So okay, so problem is that if I now there are two uncertainty. The first uncertainty, there are two uncertainty. What the first uncertainty is that how many heads would appear. If a head comes, then I draw a number between 0 and 1 at random. Okay, I draw between 0 and 1 at random. If it comes tail, then I draw at random between 3 and 4. Then I have to add it. First uncertainty is how many head will come. That is the first uncertainty. Next uncertainty is that if it comes head, any coin appears head, then what I will get from 0 to 1. There is next uncertainty. This first uncertainty comes as discrete computation, because I know if I have a set of coin, if it falls and if I break this problem into n different parts, maximum I can break into n part only. If there are n number of coins, if this if this has if this has 20 coins, then maximum I can break it into 20 parts, not more than that, not possible. This is called discrete problem. I can solve my problem by dividing problem into n part. That is true. But n is fixed only, maximum. If I have 20 coins, I can divide into 5 parts. Each part has 4 coins. That is true. But maximum I can divide into n parts only, maximum. That is the one scenario. Next scenario is that next uncertainty lies is that if I try to get a number at random between 0 and 1, if I try to get a number at random between 0 and 1, then what that number will be. Okay, now this discussion is going on breaking a problem into n parts. We will now discuss that part. Okay, what is the average number I can expect between 0 and 1? What is the average number of head I expect if I throw n number of coin? That we have calculated. Average number of head, what we get, the probability of getting average number of head. If I say, okay, what is the probability of getting k number of head? That is nck. P is the probability of getting head for one coin, and 1 minus p is the probability of getting tail on that coin. Certainly, if there is one coin, okay, 20 rupees note, coin is in kind of exclamation to the people. I have two 20 rupees coin, not one. 20 rupees coin. If I throw 20 rupees coin, then it will either appear head or tail. Consider this is a buggy coin. Okay, whatever it is. This is very bad that India is making 20 rupee coin. Earlier, 1 rupee coin was silver coin. Silver coin. 1 rupee coin. Indian metal coin that was in demand around the globe 100 years back. Silver coin from India. It was in demand around the globe. 1 rupee coin. It was till Mozambique. Mozambique in Africa. Indian rupee was in circulation till 1912. and especially the 1 rupee coin. Everyone wanted 1 rupee coin from India. That is also called Rupkani. Rupkani means, I believe, Rupkani means silver coin. One Rupkani means one silver coin. That was very famous around the globe. Europe, Africa, Australia, USA, everyone wanted to have 1 rupee coin of India. That was so nice. Anyway, I won't say that 20 rupees coin is not nice, but the way it is like, it is worth not more than one paise. If I compare it with 1 rupee silver coin, then it is more or like one paise. That's it. Means around, I believe, 22,000 times depreciation has happened for the Indian rupee. Anyway, if I toss this coin, what is probability of getting hit? Someone would say quickly, 1 by 2. Consider it is a buggy coin. Though Indian, everything what you see in India is perfect. Luckily, till now. Either you see currency or whatsoever. Whatever Indian makes is perfect. Problem is they are making very less. That is the problem. If I see this 20 rupee coin, it is marvelous. Though it is not a silver or gold coin, but it is really marvelous. There is no chance that it will be a buggy coin. Okay. So consider it is a buggy coin. Consider. Okay. If it is a buggy coin, though chance is zero. But if it is a buggy coin, then probability of getting head is P. Then probability of getting tail is 1 minus P. That is certain. 1 is P, then 1 is 1 minus P. Because if I draw, then if I toss, certainly it will appear as 1, it will appear on the head or tail. That is guaranteed. Okay, if I say, tell me what is the probability that you will get a head or tail? Head or tail. Or means plus anyway. If I say, tell me if I toss this coin, this is a buggy coin. Tell me if it will appear head or tail. Anyone will say it will appear head or tail, anything, right? Then probability is 1. How you said 1? Probability of getting head is P. Then probability of getting tail is 1 minus P. If you add, it will become 1. Or relationship means you add. What is probability of getting head? That's why I say the probability means and or. You have to understand where you have to use and you have to understand where you have to use or. If I say what is probability of getting head or tail, then there are two events. Getting head is an event, getting tail is an event. Those events are not independent to each other the way people think. If I say it is head or tail, if it is head or tail, then they are mutually exclusive in this manner. In that manner, it will come. So if I take the sample space, it will be head, tail. That will be two things come. And they are mutually exclusive to each other. There is no intersection in this in between. If I draw a sample space of a single coin, there are two outcomes will come. One will be head and one will be tail. And they are not touching each other. They are mutually exclusive to each other. If I say, tell me if it is either head or tail, then you have to add probability. This will come as 1, 1. Tell me it is head and tail. It is head and tail. It is head and tail. 0. No probability. Okay, but you said that and is multiplication. Think in other fashion. Think in other fashion. Okay, consider that there I have two coins. I have two coins. Okay. Now first coin, if I see, then it should be head. Okay. Then next coin, if I see, then it should be tail. What is probability? Then it is first should be head and another should be tail. Then it is 1 by 2 into 1 by 2. Here it will come as independence. And there it will be 1 by 2, 1 by 2. Or if I have one coin, you are giving example with one coin, right? One coin, show me what it is. It should be head. Okay, I'm seeing it. Thank you very much. Keep it back. Next time again you see. Tell me what it is. It should be head again. Okay. Now both draw, there is no relationship between each other. Next draw, if I take, that result is not dependent upon the first result. This is called independent. They are not dependent upon each other. Then it will be 1 by 2 into 1 by 2 and will become multiplication. If I toss it, same single coin. A story is going for single coin only. If I toss it, tell me it is head or tail. Then it is 1 by 2 plus 1 by 2 or will become plus. 1 by 1. Anyway, now if I have a coin and its head probability is P and tail probability is obviously 1 minus P, then if I throw n number of coin, what is the probability that k number of head will appear? That is nck p to the power k 1 minus p to the power n minus k. This is the probability of getting k number of head. This is discrete solution. This is discrete mathematics. Discrete mathematics digital way. Okay, if I try to solve this problem, what is the average number of head you expect? What is k number of head you expect? Then it is n c k p to the power k 1 minus p to the power n minus k if there are n number of coins. Okay, tell me average head. Average head means any time if I throw it, if I throw any time, what is the expectation of number of head? Okay, depends upon the luck. No luck. You tell me what is the average number of head you expect. In that case, there are many solutions. One solution is to break the problem into n different parts. N different parts, if you break, it will come on one coin. You cannot break more than n. What is the solution that we have discussed many times in the past video? Let's go to the another uncertainty. Another uncertainty is if it comes ahead. If it comes ahead, then I am going to draw a number between 0 and 1 randomly. If it appears ahead, then I am going to withdraw a number randomly between 0 and 1. Now, the question arises there also. What is the average I expect that I will draw between 0 and 1? What is average number of head I can draw? Let's throw it many times. Throw the coin one time, two times, all the coins, and count the number of head. Okay, throw it for 100 times or throw it for n times. If there are n coin and n is 20, throw for n times at least and measure the number of head. Whatever you are getting, divide by n. That is the number of average head you expect. If I draw a random number between 0 and 1, tell me what is the average number I can get, expectation or mean or on an average, if I draw, what will be the number, the most probable number I'll get. Now I cannot divide into n parts because n will tend to infinity. The number I get between 0 and 10, 0 and 1, any number I can get. 0.4, 0.499987. That number I can also get. Means number, it looks like 0 and 1, but division, any number that I get, the resolution of that number, okay, that is very high, very high. Infinite number exists between 0 and 1. Now I cannot divide into n part and then try analyzing single part and then you add it the way we have done in the average number of heads. If I try to get average number between 0 and 1, then what I'll get? That is the discussion we are pursuing. Okay, the solution starts with the let's divide into n part. No. Any number can come. Divide into n part. What is that? Divide into two parts. Let's divide your number. This is the number. This is the number, that is 0 and 1. Divide into two parts. Divide into n number of parts. N equal to 2. Then this is the first part, half, and this is the second part. Okay, now you close your eyes and hit anywhere. That is your number. Okay, if it is 0 and it is 1, if I hit here, anyway, if I hit here, it looks like 0.6, around 0.6. If I hit here, it looks like it is 0.15, this point is. Okay, anything that comes between 0 and 0.5, it will be considered as 0.5 only because we have divided into two parts. Anything after 0.5 to 1, it will be considered as 1 only. Now tell me what is the expected value you achieve from there. Then it is what is the number, that is 0.5, and at 0.5 what is the probability of getting 0.5? What is the probability of hitting this section and this section? Hitting in this section, probability is 1 by 2. Half time I will hit in first section, half time I will hit in another section. whatever is the probability of hitting in the first section and whatever is the distance if I multiply these two plus what is the distance between here and the probability if I multiply, if I add, I get the average. This many times we have talked about it. This is not understandable, right? We are trying to get the average number I get between 0 and 1, average expectation. What is the average number I get? Then I divide this 0 to 1 into 2 parts. If I get anything between 0 and 0.5, I'll consider it as 0.51. If I get anything in between, then I'll consider it as 1 1. Okay, what is the probability? What is the probability of it? Now, how to get any number here? Close your eye and hit at any point. That is the then half time I will hit in the first side, half time I will hit in the next side. So what is the probability of hitting in the next half? That is 1 by 2. Hitting in the first half, that is 1 by 2. So this distance into its probability, if I draw a bar, vertical bar, then for this the vertical bar is 1 by 2 belonging to this section. For this section, vertical bar is 1 by 2. What is the average you expect? First distance into vertical bar plus second distance into vertical bar. It is synonym to what is the average marks of the class. If class if this is the marks section, if this is the marks, then what is the average marks of the class? Now start at 0. How many? Consider there are n number of students. At 0, what is the probability of getting 0? Means how many students are hitting 0 mark? That is 4 by n. 1 marks 20 by n. 2 marks 10 by n. 3 marks 4 by n. Like that, 1 mark 30 by n. Tell me the average mark. This is marks. Then 0 into 4 by n plus 1, 1 into 1 into 20 by n plus 2 into 10 by n plus 3 into 4 by n plus 10 into 30 by n. If you do compute this mathematical expression, you get the average mark. Similarly, I'm trying to get what is the average number I'll get between 0 and 1 if I draw at random. Then solution starts by dividing into n number of parts. Then divide into 2 parts. Then getting any number from the first part, probability is 1 by 2. Getting any number from the second part, probability is 1 by 2. Then the mean will be this distance into its probability, marks into number of a student. Okay, this number into its probability, then this number into its probability. It will come as 0.5 into 1 by 2 plus 1 into 1 by 2. It will come as 0.75. You can expect 0.75 on average if you draw from that, but anyone would say this is wrong. Let's go with more number of n. Let's divide it into n equal to 4, n equal to 3, anything someone can divide. Let's divide into n equal to 4 or divide into n equal to 3, n equal to 3. Then getting this, there are 3 sections now. First section is 0.33, 1 by 3. Second section, this point is 2 by 3, 1 by 3, 2 by 3 and 3 by 3. Now getting the number from the first one third, probability is 1 by 3, 1 by 3, 1 by 3. So if I try to get the average number, then 1 by 3 into 1 by 3, 1 by 3 into 1 by 3 plus 2 by 3 into 1 by 3 plus 3 by 3 into 1 by 3. It will come as 1 plus 2 plus 3 by 9. It will come as 3 plus 2 plus 1. That will come as 6. 6 by 9. 6 by 9 is 2 by 3. 2 by 3 is 0.66. 0.6 is better than the first one we did 0.75. Means we are approaching toward the middle. Means if I grow in n, if I grow in the section, then we will get better result. If n equal to 2, if n equal to 1, then if n wherever I hit, I'll get this one only, end one. Then your average is 1. That is completely wrong. If n equal to 2, then average is 0.75. If n equal to 3, then average is 0.66. If n equal to 4, then it will come near to zero point 0.5. Means if n tends to infinity, if I chop in infinite part, then my result will be exactly same. Okay, there are two things we can see here. The first is dividing problem into n part. The way we divided our coin problem into n number of coins. Here also we are dividing into n part. But unfortunately, that result is not perfect. In coin, result will be perfect because it cannot go beyond this. So that problem of getting average number of head is actually digital problem, discrete problem. But here the problem of getting the average number between 0 to 1 is an analog problem, continuous problem. It is not discrete. But we will start with the discrete only. Now, if I divide into n part, then for each part, what is the probability of, if I close my eye and hit in any part where there are n number of parts, then what is probability of hitting in any part? That is 1 by n. If there are n parts, hitting in any part probability is 1 by n. So now each part, their number of parts are n. In each part, probability is vertical is 1 by n. If I add all 1 by n, it will become 1. It must be 1. Like if there are marks and number of students, 0 marks 4 by n. N is number of students. Number of n is number of students, total number of students in the class, and 4 is the 4 students, they got 0 marks. So at a 0, what is the probability of the 0 mark student they are getting 0 mark? 4 by n, 20 by n, 10 by n, 5 by n, 30 by n. If I add all the vertical bar, that those are by n, it will come to 1. Similarly, if I take 0 to 1 and divide into n part, what is probability of getting a number from a particular section? 1 by n. That is the probability of each section. If you add all the 1 by n time, it will become 1 1 net probability. Now tell me what is the average number you get. Now first distance is 1 by n. 1 by n into 1 by n, 1 by n square, plus 2 by n into 1 by n. Make sense? Plus 3 by n into 1 by n, plus 4 by n into 1 by n, plus, like that. At end it will come as n, I'm sorry, n by n, that is 1 into 1 by n. Okay, if you add all those, that will give you the average number you expect. How much it will be? It will be 1 plus 2 plus 3 plus 4 plus up to n divided by n square. Okay, how much it is? It is n into 1 to n, how much it is? 1 to 5, how much it is? 5 plus 4 is 9, 9 plus 3 is 2. I'm sorry, 5 plus 4 is 9, 9 plus 3 is 12, plus 2, 14, 15. Is it same as 5, 5 plus 5 plus 6, 5 into 6 by 3? Yeah, it is same. N into n plus 1 by 2 is same as summation up to n. This is what I think so. Let's try with the 10. Okay, 10, 9, 19. 19, 8, 27. 27, 7 will come as 34. 34, 6 will come as 40. 40 plus 5, 45. Okay, 4, okay, okay, up to 5 it is 34. 10 plus 9, 10 plus 9, 19 plus 8, 27, plus 7 is 34, plus 6 is 40. And here it is 15 anyway. That will come as 55. That is 10 into 11 by 2. That will be 55 again. So summation from 1 to n is n into n plus 1 by 2. What we are trying is, we are trying 1 by n into 1 by n plus 2 by n into 1 by n up to n by n into 1 by n. That will come as 1 by n square into, in bracket, 1 plus 2 plus 3 plus up to n. That will come as n into n plus 1 divided by n square. That will, I believe it is all right. I'm sorry, n into n plus 1 by 2 into 1 by n square. More or less it will come as 1 by 2 only. Means 0.5. 0.5. Okay. But It is not zero point 0.5. It is n into n plus 1. N into n plus 1 by n square into 1 by 2. If n tends to infinity, then if n is 100, if n is 1, then it is 1 plus 1, 1 into 2 divided by 2. It will be 1 1. Perfect. If it is n equal to 100, then if n is infinite, then n plus 1 will also be infinite. If n is infinite, then n plus 1, because n is number of sections we are making. If n is infinite, then n plus 1 will also be infinite. Will be n only. Plus 1 does not make any sense. Then that will also be infinite only. It will come to 1 by 2 1. Anyway, now how to solve this problem? Now we know that it will be n into n plus 1 by n square by 2. Okay, this is what we know. Okay, now, but people would say, no, 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 plus 1 and this one. I know it will tend to infinity, but it is assumption, right? You are making an assumption that n tends to infinity, but it will not be same. If it is n is 100, then if it is 1000, then net result is coming as n into n plus 1 divided by 2 into n square. That is close to 1 by 2. Close to 1 by 2. I want the perfect solution. Okay, if you want perfect solution, then this is called discrete arena is over. What is the solution that we are getting? Consider, okay, let's rephrase it. What is the average? What is the average number we will get? Consider that we are, I believe it is all right. Or can you write in the summation? I can write in summation. Summation I equal to 1. Summation, that is sigma sign I equal to 1 to n. I equal to 1 to n. I into 1 by n. This is the exact. Okay, can you do it in x? What is x? X is the actual distance from here to any I. If I belongs to this is the first section. If it is first section, then x will be 1 by n. If it fifth section, then x will be 5 into 1 by n. That is the net distance. Can you write this formula in x? Yeah, I can try. Summation I equal to 1 to n. X I is subscript. X belonging to ith section. X I into 1 by n. This is the net summation. We are trying to calculate it through integral calculus. Why we want integral calculus? If n tends to infinity, then it should give the exact result. This is what I want. Okay, that summation and plus 1, we don't want approximate. I want exact solution if n tends to infinity. What is the exact solution if n tends to infinity? Exact solution is summation I equal to 1 to n, where n tends to infinity, x, that is the actual distance from the 0 for the ith location, for the ith section, xi into 1 by n. 1 by n, I can say fx also, function over x. Now you tell me how I can calculate accurately. This is the question. Summation I equal to 1 to n x of the ith section into 1 by n, where n tends to infinity. If it is not n tends to infinity, then I have exact solution. That is n into n plus 1 divided by 2 into n square. That is the exact solution. I can say that what is the average value. But if n tends to infinity, then do not have exact solution. Okay, then exact solution lie in integral calculus, which starts from infinite only. Integral calculus gives the exact result when we chop it into infinite sections. For that, there is a separate mathematics is written, that is called integral calculus. Okay, summation works when it is discrete value, but integral calculus works if discrete manner goes to infinite. But they have different philosophy. What we want here, we want that, consider, take x outside, leave, forget the x. What we want? We want x into fx, or x bottom right xi into 1 by n. This will come in the summation I equal to 1 to n. This is what I want. Now it can be written as xi. Okay, just keep x outside and say 1 by n as a function. What I'm trying to say is that someone has, if there are n sections, if I divide this into n different sections, each section has a vertical bar. Each section has a vertical bar. If there are two sections, then there are two bars. One bar is 1 by 2 and another bar is 1 by 2, that is the probability. If there are n sections, then at the end of each section there is a vertical bar. Consider that I want to add all the vertical bar. Summation I equal to 1 to n f function over xi. For the ith section, what is function over xi? There are vertical bar of probability, right? That is 1 by n, that is fixed. If I take the top point of each the bar and connect it, it will form a function. Like a student, the 0 mark, it is 4 by n, 20 by n, 10 by n, 5 by n, like that. If I connect all the points of the top, it will give a function. I can write down what is the average marks of the class. Summation I equal to 1 to 10, because there are 10 sections. I equal to 1 to 10 x into fx. x is the x is the marks distance and fx is the height, function over x. Similarly, if I want here, then it is also summation I equal to 1 to n x into fx. Keep x outside right now and it is considered fx only. Fx is the function. What if this function is a digital function? This is not a continuous function, but still it is a function where we want the function value at discrete value of x, not in a continuous manner. Only at discrete value of x we are trying to get the value. But this is a function. What is the function? Function is 1 by n. Everywhere it is constant 1 by n. Flat line with the x-axis 1 by n. What is the integral formula of, if I say summation I equal to 1 to n function over x belong to ith section, that is constant 1 by n, whatever it is. Summation I equal to 1 to n, I equal to 1 to n, and then function over x, x belong to ith section. This summation, if I try to do with integral calculus, what will be the formation of integral calculus? Integral calculus comes in a formation of limit sign. There will be a snake sign, limit sign. X is beginning to end, not I, x. X begin to end, gx dx or fx dx, gx dx, where gx is a continuous function. If you try to get the area, if that gx is a continuous function, dx is another function. Fx we talk, that is 1 by n. Dx is another function. Dx is a function. Underneath, if you calculate the area, that is gx dx. If you say gx dx, it will give the underneath area from x is begin to x to end. That chop area, it will give the area. That is limit x is begin to end and then gx dx. That area should be exactly same as what we are doing the addition of fx. Summation I equal to 1 to n. Summation I equal to 1 to n f bracket x. X belongs to ith section because we are calculating fx at few point of the x, not in continuous manner. But whatever, we are all the vertical bar, we are adding it. Whatever we are adding it as a summation, this summation should be exactly same as the area we are calculating gx dx, x is begin to end. These two should be mathematically same. Now let's go with the integral calculus. Now integral calculus, I have gx. Gx dx will give the area underneath. This area I can divide into n different parts. Makes sense? Same thing. This area I can divide into n different parts. Each part I have a sub area. There in the summation, each part has a vertical bar. Here each part has a sub area. If I add all the n sub areas, then it will become gx dx from x begin to n. So if I have a gx continuous function, okay, if I have a gx continuous, this is gx. Okay, consider this is fx, this is gx. If this is gx, dx dx will give the area underneath up to the x-axis. And is it from this side to this side? No. Whatever limit you have put x equal to begin to end, in between what is the area? That is the gx dx will give. That area, I can divide into n different parts. Means I will make n part on x-axis between x1 and x2 in the limit, n part. Here it is 0 and 1, n part. Each part, if I calculate the area and if I add it, it will exactly become gx dx. Whereas if I take the fx, that is a summation problem, each part has a bar, means bar height should be same as the area of this strip. Then both will become same. Now we have divided in the original problem of n number of division what we made. Then each division has a probability, that is the vertical bar. Now we are adding all the probability. If I say summation I equal to 1 to n gx, that is 1 by n. So summation I equal to 1 to n 1 by n, that is gx. Means all the vertical bar if I add, it will become this summation. Summation I equal to 1 to n fx. Okay. Now this is adding all the vertical bar. This addition should be exactly same as if I take another gx and get the area underneath it. And that area, if I take from begin to end, the area, and that area should be same as summation of all the vertical bar. Now to understand this, how to get gx, summation I equal to 1 to n fx should be integration x equal to 0 to 1 gx dx. Now I have to get gx. To get the gx, now consider this is a gx function, any gx function. Gx dx means area underneath it. This area underneath it, whatever the area is coming, divide into n part. On x-axis, chop it into n part. Now they are same now. This summation and integration, they are on same plate now. Summation in one section of the cut, there is one vertical bar, that is the height. Here, in integration, in one section, I have the area in between. So if this area and vertical bar, if both are same, then I can get gx. That is the concept. So now fx equal to gx dx. What is dx? If I chop into n part, then what is the area of one section? Then dx is 1 by n. Dx is this gx dx. Gx, if this is x-axis, and this is gx. If this is x-axis and this is gx, then we have demonstrated it in, I believe, 2 weeks back out. If this is x-axis and this is gx at any random x, then this is the gx. Now we are taking gx. Now I have cut into n different parts. In one part beginning, this is the gx. If I multiply with this dx, that is the sub area, that is gx dx. Okay. Now this sub area should be exactly same as in this sub, what is fx, that is 1 by n. Means 1 by n equal to gx into dx. Dx is this area. Unfortunately, the width of one section is 1 by n and height is also 1 by n. If I chop 0 to 1 into n part, the width of one part is 1 by n, and surprisingly, the probability is also 1 by n. So luckily, so it is 1 by n equal to gx dx. Dx is 1 by n. Cut down, gx is 1. Okay, now it is multiplied by x earlier. So the repeated summation is summation I equal to 1 to n x fx. Now it is equal to, now I have to multiply with the x there also. It is now integral x equal to 0 to 1 x gx dx, where gx is 1. It will become x dx. Surprising. No, but fx is 1 by n. Here it is x into 1 by n. And summation I equal to 1 to n tends to infinity. Yeah. That will be same as integration 0 to 1 x dx. 1 by n is gone. Because gx is 1 now. Fx, that is 1 by n, equal to gx dx. Dx is 1 by n. 1 by n gone. Gx is 1. So the equivalent of the equivalent of the discrete function, that is fx, that is 1 by n, in continuous function is 1. Both are not same. I cannot write x fx and x into fx and repeated summation I equal to 1 to n where n tends to infinity is f x fx dx. Not possible. That is wrong. Fx will change because fx is height and that belongs to one section. If I do fx dx, that is height into width. Both are different. If width is 1, if I chop into n part, luckily each part has a width of 1, then I can write x fx and x fx dx, because dx, that is 1. But here it is not 1. If I grow in the n number, then it will start shrinking. The width, each width of the section will be 1 by n. Luckily height is also 1 by n. Okay, can we have another formula? Yes, we have another formula. Okay, what is another formula? What is the height? What is the height of the any section? Height of the any section is 1 by n. That is fixed. What is the height of what that is equivalent to the area of that section? If I take any ith section, if I divide x axis into n part, then first section, second section, third section, ith section, last is nth section. Ith section, if I take the probability, that is called discrete probability. It is also called mass function, point mass function. It's a point probability. Point mass function is 1 by n. Okay, whereas the continuous function is gx, that is 1 that we have said. If it is 1, then for the ith section this area will be exactly 1 by n. What is the area of the ith section? If I take the continuous manner, that is gx dx between, if this is x minus 1. I mean, if I take the first section, then it is 0 to 1. If x I have taken as 1, then I have to calculate area between x and x minus 1. Makes sense? If I take the first section, if I say I have divided into n part and each part has probability 1 by n, the first part is bounded between 0 and 1 by n and it has probability 1 by n. If I talk in integral calculus, then there is another function gx. Gx dx integration from 0 to 1 by n, the area should be exactly what we are talking is the vertical height, that is 1 by n. Okay, vertical bar, all vertical bar we are changing it to continuous function. That is one we are saying. Let's try now. In the first, the vertical bar is 1 by n, that is guaranteed. In the first, what will be the integration? That is gx dx integration from, or any x, integration from x minus 1 by n to x. If it is 1 dx, then it is x. Integration will be 1 dx, the dx is 1. 1 dx is x, from x minus 1 by n to x. That will be x minus x plus 1 by n. It will come as 1 by n only. This is what we want. Okay, means in any section, whatever the vertical bar is, it should be exactly same as whatever I sample at that point. If it is a continuous function, I can sample at any point. If I sample at that point, then in that section, what is the sub area coming? Area should be exactly same as vertical bar in the discrete manner. If both are same, then we can say what will be the continuous function. Okay. Let's try another one. What is your another one? Another one is, we started discussion that the average expectation, what we expect from the continuous manner is x into fx summation I equal to 1 to n tends to infinity. X belongs to ith section, fx, that is 1 by x fx. Now tell me, for fx, what will be gx? You're talking like, right? Okay, if I do like that, then x into fx is the height. If I multiply both, then it will be again a height on the ith section. That is x into fx. That should be same as gx dx integration of the ith section. Make sense? Now gx dx we have taken and we have divided into n part, then dx is again 1 by n. Okay, then it is x into 1 by n, and there gx into 1 by n. Again, then gx will be x. Then again gx will be x1. Means if I say exactly convert x fx I equal to 1 to n to gx dx, x is from 1 to n, then gx will be x because dx is 1 by n, and here luckily dx is the width of the nth section, and luckily fx this side height is 1 by n. They are cutting each other, and gx is x. So more or less it is coming same thing. Either you from fx you get gx, or x into fx you get gx. Doesn't matter in this case. Otherwise gx will be d of x because x will go this side, dfx by dx. This will be gx. Someone can try. Anyway, this is the way that we compute the average length. Okay, tell me the average length. If I draw from 0 to 1, what is the average length? That is x 0 to 1, x 0 to 1, x into gx dx, where gx is conversion of fx, that is 1 by n. Then gx is 1, x dx, x square by 2, 0 to 1, 0 to 1. Then it will be 1 by 2. 0.5 is the average. Okay, tell me between 3 and 4. Between 3 and 4, gx is 1. Dx, dx, x between 3, x square by 2. Now you tell me. X square by 2, 3 to 4. It is 3 to 4. 4 is 3 to 4. 4 is 60, and 3 is 9. 9 minus 16 minus 9. That will come as 7. 7 by 2. Hop, hop, hop. Wrong answer. We'll try again. Okay. What is the average between 3 to 4? Then limit will be 3 to 4. And then x gx dx. Gx is 1. So x dx, x square by 2. Then it will be 4, 3 to 4. 16 by 2 minus 9 by 2. 7 by 2. 3.5. Yeah, that is the average. 3.5. Perfect, right? Okay, but this is not that easy if fx will also be a function of x. Right now fx is 1 by n, and luckily it is meeting dx, that is also 1 by n. Then it is working. Anyway, we will complete this example in next session. So now we know what is number of head. If I throw n number of point, what is average number of head? And then if it comes head, then I get a number between 0 and 1. That average is 0.5. Here, if it comes tail, then I draw from 3 and 4. Then again average is 3.5. Okay, and here what is average number? If I mix all together, then what is the average average number I'll get if I add all those? We will talk in next. Okay. So please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Probably this explanation you would not find in the book.